Welcome back to my training series entitled Understanding EMV. We are currently in section 3, which is an introduction to EMV. In this video, we will cover the following topics. Firstly, a background to EMV. We'll talk about what is a chip card. We'll look at the different reasons why chip cards were actually introduced. We'll do a comparison between chip cards and magstripe to determine or to prove how chip cards are more safe, more secure than magstripe cards. And we'll close this video off by having a quick discussion around the value adds that EMV brings to the card and payments world. Okay, so let's get straight into it. So, firstly, EMV. What does EMV stand for? EMV is an acronym for Europay, MasterCard, and Visa. And these were the three companies that originally cooperated to develop a standard for chip-based card payments. In 2002, Europay was merged into MasterCard, so Europay International does not exist anymore, but the name EMV has endured. In 1999, EMV Co. LLC was formed, and it was formed as a cooperation between, at the time, Europay International, MasterCard International, and Visa International. And the purpose was to manage, maintain, and enhance the EMV integrated circuit card specifications for payment systems. EMV Co's primary role is to manage, maintain, and enhance the EMV integrated circuit card specifications with the objective of ensuring interoperability and acceptance of payment system integrated circuit cards on a global basis. Since 1999, the membership of EMV Co has grown. So we had, Europay International, MasterCard International, and Visa International. Obviously, as discussed, Europay no longer exists, but the membership has expanded. So now it's MasterCard, it's Visa, it's American Express, JCB, and UnionPay. Now, each of these organizations owns an equal share of EMV Co and has representatives in the EMV Co organization at both the management and working group level. Okay, so that's just a basic background in terms of what EMV is. Point to note, EMV is an acronym, and what you'll find is as we progress through this course, acronyms are very much the flavor of the month when it comes to EMV, so be prepared to be bombarded with acronyms from all sides. Alright, so let's move over into what exactly is a chip card. So a chip card, or a smart card, or an ICC, is a payment plastic with a microcomputer embedded into it. And this microcomputer takes the form of a microchip. Currently, we are now in 2022. You'll find that most chip cards still retain the magstripe on the back of the card. And the purpose of this is simply to allow for association branded cards to be accepted globally, even in markets where EMV is not fully deployed yet. So basically what we're saying is, we have a card which traditionally was a magstripe card. We've added a computer to this, and remember the computer is in the form of a tiny little microchip which has hardware, it has software, it has an operating system, it has applications, and it can be programmed to produce certain outputs. And so when you combine these two, what you end up with is an EMV card or a chip card. Okay. But the question that may be keeping you up at night is, why chip cards? Okay, so what was the purpose? Why did we need to go down this road of this very complex EMV technology? Okay. And this has its roots back in the old, or the bad old magstripe days, right? Where we found that magstripe cards were heavily susceptible to both counterfeit fraud and lost and stolen fraud. Now, let's talk a bit about lost and stolen. Lost and stolen, my card fell out of my wallet. Bob picked it up. He went to a shop. He purchased a pair of socks, and he paid for it with my card. And he'd swipe the card. The transaction would go up. At this point in time, I'm not aware that my card had been either lost or stolen, so I haven't reported it. So the transaction goes online, the transaction gets approved, Bob signs the receipt with a signature, and the signature need not necessarily match my signature on the signature panel on the back of the card. The chances of the teller or the attendant actually comparing the two signatures are very low. I think I count on one hand the number of times I've actually seen an attendant compare the signatures, right? So because these magstripe cards were usually signature based, this type of fraud was prevalent, and the numbers were increasing meteorically. Okay. The next type of fraud was counterfeit fraud or skimming, which I'm going to be discussing in a bit more detail in the next slide. But basically, this is where we clone cards, right? Where I have the means to create a card that will behave as like a card that belongs to an actual card holder. So let's talk a bit about skimming. Okay. So before we talk about skimming, let's first take a trip in our DeLorean back to the 1980s. And back in the 1980s, these two items were fairly commonplace, right? So you had a cassette tape, which is this little blue object here, and then you had a tape player or tape recorder. And this was a fairly common one, but it came in various sizes and shapes, right? And what you would do is you would take the cassette and you'd put it in the player and you would press play, and the player would convert the data stored on the magnetic tape on the cassette, and it would translate it into, in this case, audio, right? So be it a song or be it someone speaking or whatever it is. Right. So what's actually also important to understand is that not only could you play, but you could also record. So if you put a tape in and you press the play and record button at the same time, it would record whatever audio feed came in through the microphone, and it would write, it would convert the data to binary, and it would write this data to the magnetic stripe. So the technology of reading and writing to a magnetic tape was extremely commonplace back in the good old days. So what this means is that back in the day we had magstripe cards. Now, if you look at the magstripe at the back, you generally had two pieces of data encoded on that magnetic tape, right? And it was a lot simpler and a lot shorter than a song on this cassette, right? So you basically had track one, and track one, this is a sample track one, and so it literally looks like this, and this is sample track two. Okay, so there's a very short strings of data encoded on this mag tape, and the technology to read and write to this was almost exactly the same as the one we spoke about earlier. So what does this mean? It means that the ability to both read and write to this magnetic tape was commonplace, which meant it made it very easy to counterfeit. Okay, so this brings us to the next part where we talk about skimming. Okay, so what you're seeing here is a skimming device, which you can buy off eBay or Amazon at a very cheap price. And what would happen is this, right? So Bob would go to a restaurant and he'd have a meal, and at the end of the meal, the waiter would come over and say, "Mr. Bob, how would you like to pay?" Bob would say, "I'd like to pay with my credit card, of course." And so the waiter would hand Bob the check or the bill. Bob would sign the bill, add the tip, come to a total value, and he would then hand his magstripe card to the waiter. Now the waiter could have been a very naughty waiter, so he or she would need to walk the card from Bob's table to the till. Remember, in those days the terminals were not mobile; they were stationary next to the till points, and process the transaction at the till and bring the slip back, and then Bob would sign the slip while still seated at the table. But in the journey between the table and the till, what the naughty waiter would do was he would simply swipe the card through a skimming device. Now you can see how small the skimming devices are, and these would be strapped to the wrist or held in the palm. So it could be done covertly, swipe it through. It's not a bold gesture that people can easily see, and this was commonplace, right? So, Bob would the waiter would process the transaction, return to the table, hand Bob the slip. Bob would sign it, and then Bob would leave. But what Bob didn't know was he had left an additional tip for the waiter, because later that night, the waiter would take the skimming device, hand it to his buddy who was out of his mom's basement, and his buddy would connect the skimming device to a laptop, dump all of the cards that had been captured during the course of the day. So they'd have an array of track 1 and track 2 data sitting on a file. They'd have a card encoding machine, so it's another machine that you can buy off eBay or Amazon that would connect to the laptop. You put a blank card in there, and you would literally write track 1 and track 2 to the back, to the magstripe on those blank cards. You put a pretty sticker on the front and back to make it look like it's a bank issued card. And what this means is you can now take this card and you can transact against Bob's account, until he actually notices these strange transactions on the statement and reports them, and then suspends the account. Okay, so these were the challenges that led to the creation and the implementation of EMV. Okay. So, just bear in mind, EMV, as I've said before, is extremely complex. So what they did was they took a bunch of extremely intelligent propeller heads, they shoved them into a dark basement somewhere, they threw in a couple of pizzas, some energy drinks, and locked the door and told them, hey guys, come up with a plan to prevent lost and stolen fraud and counterfeit fraud, and you guys are not coming out until you manage to come up with a plan. So what these very intelligent people did was they came up with EMV. And yes, it's extremely complex, but it needed to be complex. Okay? And it's complex because it's meant to prevent, it's meant to mitigate against the lost and stolen fraud, and it's meant to prevent skimming or cloning completely. And, I would say in my experience, it has achieved this. Okay? So, with all this complexity that we now introduce into the landscape, let's talk a bit about how are chip cards more secure than magstripe. Right, so let's go to magstripe up against chip. So, in the magstripe world, the card is not an active role. So, remember, when you swipe Bob's card on the terminal, the only thing that happens is the terminal reads the data of the magstripe. Once the card has been passed all the way through, Bob can return that card into his wallet. Because the card is no longer a participant in the transaction. It has supplied the track 2 data to the terminal, and the terminal will now determine how the transaction proceeds going forward. Right? In the chip world, this is very different. So what you find that in the chip world, the card itself has independent decision-making capability. So it's a computer, it's a system in its own right? It's a system with decision-making capability. Right. Next, in the magstripe world, our terminals performed only 2 types of risk management. The first one was hot card list or exception file processing, and the second was terminal flow limit risk management. Okay, so let's talk a bit about hot card list. Hot card lists were basically, when a card holder reported his card stolen, the issuing bank would flag this card number. And on the terminals, they would load this card number. So during a transaction, the terminal was expected to read the card number and see if it could find a match on the hot card list. And if it did, it would decline the transaction immediately. Right. The problem with this is that the terminals don't have infinite amount of storage. So as an example, let's say that terminals could only store, say, 1,000 records. What you'd find is that the acquiring bank, if they had an issuing division within the bank, they would give preference to the issuing division. So of the 1,000 records, so let's use Bank ABC as an example. Bank ABC has a terminal in the market, and they have an issuing division, and the issuing division has flagged so many cards are being stolen. So of these records accounts being flagged, Bank ABC would store, let's say, of the 1,000 available record spaces, they'd allow Bank ABC itself to store 400 card numbers, and then thereafter every other bank within that country would be allocated, let's just, as an example, say 100 records. So the problem you've got with this is that your card will be on the terminal for a very short period of time, because you'd have to cycle the older card numbers off so that you can bring new card numbers on, right? So you've got 100 card numbers, and then just every 2 or 3 days, the oldest records are removed and newer records are then introduced. So the banks would need to supply this list to one another, which is labor intensive, and remember that these card numbers would stay on. It would cycle through this hot card list, maybe over a period of a week before it moved off again. So if I was a clever fraudster, I would steal a card and I just would not use the card for a period of 2 weeks, when I'd be fairly comfortable that the card number has appeared on the list and then it's been removed from the list. So when I start using the card again, guess what? Right? It's not flagged, so the transaction, I could potentially complete offline transactions here. Okay, which brings us to the second point, which is now terminal flow limit management. So back in those days, the terminals had a static value. So as an example, we had a store and the flow limit is 300 rands. As long as I kept my purchase value under 300 rand, I could indefinitely process offline transactions. So even though the card has been flagged as stolen on the host system, right? If the transaction never reached the host system during an offline transaction, the host isn't aware of it. It isn't given an opportunity to decline a transaction. So I could go shop to shop and just do low value payments under $300, and I'd be able to buy stuff off the stolen card. And the first time that the bank would actually know that this card has been transacted with was later that day when the terminals batch and all of these offline transactions were transmitted back to the host system and aggregated. Okay, so now obviously you can see how risky this is. So if you look at the chip world, the terminal now has advanced risk management capability. Right? So yes, hot card lists and flow limits are still in place, but there are about 40 different checks that the terminal will now do. It does its own terminal risk management to help it mitigate this risk. Okay, the third comparison is where we speak of the card holder, and we've touched on this a bit before. We were dependent on the terminal attendant, the cashier, to actually take the signature that you scroll on the receipt and compare it to the back of the card, and if there was a match, good. And if there wasn't a match, if the signatures didn't compare, what were they supposed to do then? So what you could find is, and my experience has been this, is that cashiers very, very rarely did that comparison. Okay? In fact, after you swiped your card, you'd put it in your wallet and the receipt was given to you, which you signed, you'd hand back and you'd walk away. There was no check done whatsoever. Okay? This is different in the EMV world. So in the EMV world, we do active verification of the cardholder, and usually it's through PIN. Signature is still supported, but you find that there are newer ways of cardholders being validated, like biometrics and facial recognitions coming through and stuff like it. Okay. Finally, or the fourth point is we talk about transaction decisioning. Right? So in the old magstripe world, your final decision was made by the host, right? And we're speaking of an online transaction. Obviously, for an offline transaction, the final decision was made by the terminal, right? But if you look at the online decision, the terminal was forced to comply with whatever outcome the host system supplied it with. In the chip world, this is very different. So we have to make reference to something that is called the golden rule. And the golden rule states the strictest rule always applies. Okay. So in the chip world, the final decision is not necessarily made by the issuer host system. The final decision is always made by the card. Now it could agree with the issuer host system, but under certain conditions it could actually override the issuer host systems. And we'll discuss this in further detail as we go along, right? But just want to say that the final decision in the EMV world is made by a card, and we have the strictest rule applies, which is the golden rule, and which means that there will be multiple inputs into the final decision, and the one that is strictest will apply. Okay. So let's talk a bit more about how chip cards are more secure than magstripe cards. So as we've touched in the last point in the previous slide, we've got decision making by the card. So because the chips are systems in their own rights, okay, we are no longer dependent on the terminals to decide on the outcome of the transaction. The chip will perform its risk management. The terminal will perform its risk management. If there's an online host in the mix, they will provide their risk management, and all three will come together. We'll apply the golden rule, which is the strictest rule applies, and this will be the transaction outcome. In the EMV world, we have ways, or we have measures to validate that the card being used in the transaction is not skimmed and it's not cloned. Okay, we have a means to verify that the card is a genuine card issued by a valid card issuer. Okay. This process is called card data authentication. Okay. It's also called CAM, card authentication methodology, and ODA, offline data authentication. And this is a cryptographic process processed by the terminal and supported by the card to validate that the card is genuine and is not cloned. Okay, and we're going to talk about this in a lot more detail when we actually do the acquiring session, specifically the EMV transaction. The next point is cardholder verification, which we've touched a bit on in the previous slide. So remember, we've introduced stringent measures around decision making. We've introduced stringent measures to authenticate that the card is not cloned, that it's a genuine card. We've now got improved measures to verify that the cardholder is a genuine cardholder. Now, generally, this involves use of a PIN, so we can now support PINs, and obviously there's various types of PINs, online PINs, offline PINs, plain text PINs, encrypted PINs, and we'll touch on those a bit as we go along. But as we've indicated before, there are also other CVM types like biometrics, facial recognition, etc. Okay. And finally, we have a very interesting notion called online mutual authentication, or OMA. Now, this is a very interesting process. It happens during online transactions only. The term mutual denotes that there's two parties involved, so there's a handshake of some sort. And what this means is, during an online transaction, when the online host receives the transaction, it has a way to verify that the card being used is authentic. Okay, so this is over and above the offline card authentication done by the terminal. The online host also has a way to verify that the card is authentic. When the issuer host responds to the message, right, and it reaches the terminal and it reaches the card is not going to take it for face value that the issuer response has come from a genuine issuer host system. Okay, it's going to be suspicious, and it's going to say, before I proceed with an authentication decision, an authorization decision, I first need to validate that the message I've received actually has emanated from a trusted and from a genuine issuer host system source. Okay, so the card itself will verify that the host system responding is genuine. That is not, it's not, some fraudster in his basement who's managed to intercept the transmission stream and inject his own response in there. Right? And in certain instances, if the card is not satisfied that the issuer host response was genuine, it would override that issuer host decision, and it would decline the transaction. Okay. So I think you can all agree that we've introduced, or EMV rather has introduced significant measures to make the card payments very, very secure. Okay. But what we found was, in addition to the security, what EMV gave us was the ability to also introduce some value adds, to increase profitability and to improve user experience, basically. Okay? And some of these value adds are data storage. So because it's a computer, because it has internal storage, you can actually store information on a chip card. And I mean, I've got examples in internet favorites, medical history, etc. But I mean, based on your business model and based on the capacity of the card itself, how much of storage is available, you could decide what sort of information you want to store on the chip. It's possible to run loyalty programs off chip cards. And, this is where you don't necessarily need a host system to run the program. You can have the card itself, do the points deductions and the points allocations on the chip itself. So everything is maintained and run offline on the card. It is possible to create secure internet transactions, and by this we mean, generally speaking, an internet transaction is referred to as a card not present transaction, right? So you're on the merchant portal, you've made a purchase, you enter your card details, it's a card number, you enter a CVV number, you may enter through the secure number, and then that's done, right? So you don't necessarily need to have the physical card present. I could walk past someone's desk, where they've got a card lying there, and I could take a picture of the front of the card, take a picture of the back of the card, and I could, use the card number, the expiry date, and the CVV to make purchases from an online portal without me actually having the card, right? So EMV allows us to convert card not present transactions into card present transactions if you as a business want to support this. And one of the ways that they did this was, you as an issuer could supply your card holder with a PIN entry device or a PIN reading device. And what this means is that, if the merchant supported this, during a transaction, you would take your card, you would insert it into the PIN entry device, and you would capture your PIN. The card would validate that the PIN is correct, and if it was, it would supply you with a 6 or 8 digit code. When you're doing the purchase online, the merchant would prompt you for that 6 or 8 digit code which you'd enter. And that would then be proof that not only was a card present, but a PIN was required and a PIN was correctly entered to secure this transaction. Right. And obviously, the biggest one, which is contactless payments. I think in this day and age, we are all comfortable, we all used to contactless payments. But it's important to note that contactless payments runs off an EMV rail. Okay, so be it a contactless card, be it an NFC-based transaction with a virtual card on your mobile phone, there's various form factors available. You can get an EMV card embedded in a key fob, in a necklace, in a chain, in a sticker, and these would operate under the very same EMV standards that we are discussing as part of this training course. Okay. Right. So this brings us to the end of this video. It brings us to the end of this section called Introduction to EMV. And I look forward to catching you guys in the next video.